talking about a linear function. We're talking about a line. There's all kinds of different functions. There's a linear function, there's an exponential function, there's a quadratic function, there's a quartic function, a cubic function. Okay? All of these functions have what we call the parent function. It's basically the baseline. So this is your baseline function. Okay? When we talk about transformations, most of the time we're referring back to the parent function. So if you hear me say linear parent function, anytime I say that, we're talking about y equals x. So if I have y equals x, 0, x, or f of x equals x, right? It's the same thing. What's the slope of that function?
It's 1.
1. 1. What's the y-intercept of that function? 0. If there is an x, it can't be 0x, y'all, or else there would be no x there, right? So if it's just x, the coefficient is 1. But if there's nothing being added on to the end, it's 0. So when I graph this, that is your parent function going through the origin, slope of 1, going on forever and ever and ever in each direction. So what would be a reasonable domain for that parent function? Infinite, right? And we can either write negative infinity is less than x, which is less than infinity, or we could keep it simple and just write all real. So these are the same thing. Okay? So if it ever touches everything, that's just all real. So then what would the range be? Same thing, all real. If it's everything. So see the arrows are going off infinitely in each direction. So you can write negative infinity is less than x, which is less than infinity. Or the same thing could be said for all real numbers, because that encompasses everything except imaginary numbers, which we want to get to here. Okay. Let's make some comparisons. So let's graph our parent function first. If you have multiple color pens, this would be a good time for those. Not getting into the colorful side yet. F of x equals x. We're going to graph our parent function. So it goes through 0, slope of 1, there is your parent function. And we're going to graph these other 5 functions along with it, and then we're going to make a comparison back to the original. So everything is being compared to this black line or your pencil line on your paper, okay? So the first transformation, or the first equation that we're going to graph with it, f of x equals 5x. What changed?
So
The slope. What happened to the slope?
well,
It increased. So then when I graph it, we're going to say, okay, well, what happened to the equation? And then there's going to be a second bullet point that's going to say what happened to the graph, okay? So my slope increased. Now it's 5 over 1. So 1, 2, 3, 4, 5. It's so hard to see those. 1, 2, 3, 4, 5 over 1. change my line?
Did it get more?
Steeper. My line got steeper because I increased my slope. So if I'm increasing my slope, can I always say if the slope increases, then my line's going to get steeper? Okay, that's something that would always be true. My slope increases, my line is steeper. Okay, my next equation, f of x equals I messed that up in all kinds of ways. 1/4 x. So based on that parent function, what happens?
It's gonna get flattened.
You're making an, I guess hypothesis, we're bringing some science. If my slope decreased, Maddox says that my line's going to get flatter. Do you guys agree? I would agree too, but let's just double check. So instead of up 1/1, it's up 1/4. Was this hypothesis right? Yes, it was. All right. Go to the next color. Number 3, f of x equals x minus 4. What changed?
Negative.
The y-intercept. What happened to the y-intercept? Well, it started at what?
Negative. Oh, it starts at zero.
It started at 0. Where is it now? So what happened to the y-intercept? It went down. It decreased, right? So my y-intercept decreased. My slope didn't change though. So my slope is still 1, but I start 1, 2, 3, 4 units down. What kind of relationship did that new line have with the black line?
Parallel.
Parallel, same slope, different y-intercept. So what can I say as far as transformations are concerned? What happened to that black line to create the green line? It went down. It shifted down 4 units. Which makes sense, right? If you're just changing the y-intercept but not the slope, the line itself is just shifting, but staying, like the slope itself is staying the same. So then, if I said f of x equals x plus 10, the y-intercept increase, what do you think is going to happen to my line? It's going to shift up. Plus 10. Is the purple line also parallel to the black line? Yep. Same slope, different y-intercept. That means my line just shifted up. At least f of x equals negative x. What happened?
It shifted.
No, the negative one.
Slope switched signs. The slope switched signs, and yes, Ryan, that means that my line is going to be going the opposite direction.
That's a pretty good one.
So my line went from +1 to -1. If I swap the sign, it went from +2 to -2. What's happening to the graph?
It's getting less good.
It's not necessarily perpendicular. This one, for this case, is only because the slope was 1. But if the slope was 2 or -2, that wouldn't be perpendicular. Think about what's happening to your line.
It's
No, it would be -1 over +1.
there's a negative one over negative one. It's turning 160 degrees. No,
80.
it's 80.
It's flipping. If we're talking about transformations, think back to transformations last year. What happens? What do you call something that flips on a graph?
Rotation.
Oh, that's turn.
Wait.
Reflection. Reflection. This is linear transformation. Okay, so each one of these is one single transformation. If your slope increased, that's one transformation. If your y-intercept changes, that's one transformation. If the sign of the slope switches, that's a single transformation. Okay? So let's put all of this together. Write an equation that would change the graph of the parent function. So remember, f of x equals x accordingly. It shifted up to and flipped over the x-axis. How many transformations? 2. Shifted up 2. What does that change? The y-intercept. What's going to happen to the y-intercept? You're going to add 2. Flipped over the x-axis. What kind of change is that? Reflection. So it's going to change the slope to the opposite side. So if I started off with f of x equals x, and I went opposite sign and I increased my y-intercept, what is my new equation? Negative x plus 2. Very good. Flatter by 1/4 and down 3. How many transformations is that? 2. Flatter by 1/4.
Slope. That's the slope.
Slope. Changing the value of the slope. Good. And down 3. The y-intercept of b minus 3, right? So if I started with x and my slope is flatter by 1/4, what's my new slope? No, it didn't reflect. Okay, you can say 1/4. I've had people that have subtracted it, flatter by 1/4 and made it 3/4. I would take either one because of the way that that's worded. It's not very clear. So if you wanted to put f of x equals 1/4 x, but then my y-intercept is clear. What's my y-intercept? -3.
It would technically not be wrong because you said it's minus. You have to subtract 1/4.
I would have also taken this. It says flatter by 1/4, so if, depending on how you're reading it,
Take it from 1, subtract.
subtracting it from 1. Yes, flip it over. So, describe the transformation transformations on the graph of the parent function f of x equals x that result in g of x. So all of these are after a transformation. Put up on the phone. Okay, these are after transformation. First things first, I'm going to do these first two with you. How many transformations have occurred in that first equation? 2. 1, 2. What is the first transformation that occurred? Negative. So what happened? What's the transformation? Reflect. The negative, if the sign switches of the slope, it's just a reflection. That's all I need from it. Okay, and then the second transformation of 9. Good. How many transformations occurred in the second one? 1. What happened? It was flatter. All we have to say is flatter. Okay? You guys do the last 3. Bring it back. How many transformations? The next one? 3. What's the first? Reflect. Then flatter. And then up 5. Very good. Okay, next one. How many transformations? 1. Steeper.
Isn't that the same thing?
Okay, time out. The slope increased. What does that do to the line? You are talking about the effects on the graph. So all of these ones that we did over here, we're looking at the second bullet. That's the result on the new graph. I'm not asking what happened to the equation, because that's what the first bullet was. What happened to the equation? Then we looked at the graph. Equation, graph, equation, graph. So if it asks what results on the graph, what you're going to tell me is that it's steeper, okay? Because I can see that the slope increased, but you guys need to tell me what that means for the graph. So then the last one, how many transformations? 2. Steeper and what else? Good, down 8.
So, like, if it tells you what's on the graph, you just write, like, steeper down 8.
Okay. Use the parent function and the description of the transformation to write a new function. So now we're writing a new equation. Transform the graph of negative x plus 2. So we're not starting with the parent function here, but we're using the parent function as our kind of guide. In such a way that has the same steepness in the opposite direction. Did the y-intercept change? No. Same steepness in the opposite direction. What would that be? The slope has to change sign. It's a reflection, so that would make my new function f of x equals x plus 2. We just changed the sign. Okay. Reflect x minus 1 across the y-axis. Right now, don't worry about the axis. So just reflect, and then translate 4 units down. So reflect means, what am I doing? Changing the sign, so it's now negative x. Then 4 units down, but it was at minus 5. Yes. You were yes, you are on the and that you're actually right. You would be determine how the changes will affect a new graph, then write an equation. So we're talking about the effects on the graph and then writing a new equation. For large parties, a restaurant charges a reservation fee of $25 plus $15 per person. The total charge for a party of X amount of people is f of x equals 15x plus 25. How will the graph of this function change if the reservation fee is raised to 50 and the per person charge is lowered to $12. How many transformations? 2. What did they describe first? They increased the wine percent by how much? 25. So what happened to the graph? Up 25 units. It went from 25 to 50. What else did they tell you? They lowered the slope, which would do what to our line? Flatter. Now, I need to make a new equation. F of x equals 12x plus 50. Good. Okay. Y'all do these two. Yes, I'm going to go back up. Chaperone, how many transformations? 2. Flatter. Wait. It's steeper. It went from 1/4 to 1/3. Steeper. Down 2. What was your new equation? Okay. For part A, what change would the graph have?
Why is it?
The graph, what would that mean? Down 15.
Did you say up 60 or down?
No, it went from 75. So then it's C of t equals 40t plus 60. Okay, part B refers back to the original. So what happened? Flatter. And it would be C of t equals, some people are packing up and I am not done yet. 30t plus 75. It goes back to the original. Now it says, what if both changes? Very good. Now, your homework is those last few problems. Bring them with you to class tomorrow. There is a submission on Canvas, but that is for KBA, not for you.